So yesterday I read the introduction of the book, including some pages from the first chapter. But what I forgot to do was that to discuss about the things that I learned from reading the introduction. So exactly I am going to do that now. And also I highly recommend buying the book, The Beginning of Infinity by David Deutsch. It's an amazing book. You can learn a lot, hopefully. So here's what I have learned from reading the book. No, not the entire book, the introduction. So here's how the first paragraph of the introduction goes. Progress that is both rapid enough to be noticed and stable enough to continue over many generations has been achieved only once in the history of our species. It began at approximately the time of the scientific revolution and is still underway. It has included improvements not only in scientific understanding but also in technology, political institutions, moral values, art, and every aspect of human welfare. So, the information I can deduce from this paragraph is that it argues that significant progress in human history has only occurred once, beginning with the scientific revolution. This progress has encompassed various aspects of human life, including science, technology, politics, morality, art, and welfare. While some influential thinkers have denied the existence or value of progress, the author asserts that there is an objective distinction between true and false explanations, success and failure, and right and wrong. The author contends that all progress, theoretical and practical, stems from the human pursuit of good explanations. So it seems to me like explanation is everything. The way we define friendships, relationships, is and also business is 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 hugely dependent on the explanation that we tell, the stories that we tell, the explanation that we provide. So this quest is uniquely human, but its effectiveness is grounded in the universal laws of nature that serve as good explanations. This connection between the human and the cosmic suggests a central role for humanity in the grand scheme of things. The text concludes by exploring the possibility of infinite progress, arguing that it is indeed possible and that understanding the conditions for and against progress is crucial. And then the last paragraph from the introduction is it goes like this. Must progress come to an end, either in catastrophe or in some sort of completion, or is it unbounded? The answer is the latter. That unboundedness is the infinity referred to in the title of this book, explaining it and the conditions under which progress can and cannot happen entails a journey through virtually every fundamental field of science and philosophy. From each such field we learn that, although progress has no necessary end, it does have a necessary beginning, a cause or an event with which it starts, or a necessary condition for it to take off and to thrive. Each of these beginnings is the beginning of infinity as viewed from the perspective of that field. Many seem superficially to be unconnected, but they are all phases of a single attribute of reality, which I call the beginning of infinity. So here the text, the author emphasizes that progress is not limitless, but rather has a specific beginning. This beginning can be attributed to a cause, an event, or a necessary condition that allows progress to start and flourish, while these beginnings might seem unconnected. Now let's move on to the first chapter, which is labeled the reach of explanations. So here's a quote which was written by John Archibald Wheeler and also the New York Academy of Sciences, 1986. So he wrote this. Behind it all is surely an idea so simple, so beautiful, that when we grasp it in a decade, a century, or a millennium, we will all say to each other, how could it have been otherwise? So here's the first chapter of the book. The unaided human eyes. The universe beyond our solar system looks like a few thousand glowing dots in the night sky, plus the faint, hazy streaks of the Milky Way. But if you ask an astronomer what is out there in reality, you will be told not about dots or streaks, but about stars, spheres of incandescent gas millions of kilometers in diameter and light years away from us. You will be told that the sun is a typical star and looks different from the others, only because we are much closer to it, though we're still some 150 million kilometers away. Yet even at those unimaginable distances, we are confident that we know what makes stars shine. You will be told that they are powered by the nuclear energy released by transmutation, the conversion of one chemical element into another, mainly hydrogen into helium. Some types of transmutation happen spontaneously on Earth in the decay of radioactive elements. This was first demonstrated in 1901 by the physicists Frederick Soddy and Ernest Rutherford, but the concept of transmutation was ancient. Alchemists had dreamed for centuries of transmuting base metals, such as iron or lead, into gold. They never came close to understanding what it would take to achieve that, so they never did so. Scientists in the 20th century did, and so do stars. When they explode as supernova, base metals can be transmuted into gold by stars and by intelligent beings who understand the processes that power stars, but by nothing else in the universe. As for the Milky Way, you will be told that, despite its insubstantial appearance, it is the most massive object that we can see with the naked eye, a galaxy that includes stars by the hundreds of billions, bound by their mutual gravitation across tens of thousands of light years. We are seeing it from the inside because we are part of it. You will be told that although our night sky appears serene and largely changeless, the universe is seething with violent activity. Even a typical star converts millions of tons of mass into energy every second, with each gram releasing as much energy as an atom bomb. You will be told that within the range of our best telescopes, which can see more galaxies than there are stars in our galaxy, there are several supernova explosions per second, each briefly brighter than all the other stars in its galaxy put together. We do not know where life and intelligence exist, if at all, outside our solar system. So we do not know how many of those explosions are horrendous tragedies. But we do know that a supernova devastates all the planets that may be orbiting it, wiping out all life that may exist there, including any intelligent beings, unless they have technology far superior to ours. What a sentence! I am reading it again. This sentence is amazing. But we do know that a supernova devastates all the planets that may be orbiting it, wiping out all life that may exist there, including any intelligent beings unless they have technology far superior to ours. Its neutrino radiation alone would kill a human at a range of billions of kilometers, even if that entire distance were filled with lead shieldings. Yet we owe our existence to supernova. They are the source, through transmutation, of most of the elements of which our bodies and our planet are composed. There are phenomena that outshine supernova. In March 2008, an X-ray telescope in Earth orbit detected an explosion of a type known as a gamma-ray burst, 7.5 billion light-years away. That is halfway across the known universe. It was probably a single star collapsing to form a black hole, an object whose gravity is so intense that not even light can escape from its interior. The explosion was intrinsically brighter than a million supernovae and would have been visible with the naked eye from Earth, though only faintly and for only a few seconds, so it is unlikely that anyone here saw it. Supernova last longer, typically fading on a timescale of months, which allowed astronomers to see a few in our galaxy even before the invention of telescopes. Another class of cosmic monsters, the intensely luminous objects known as quasars, are in a different league. Too distant to be seen with the naked eye, they can outshine a supernova for millions of years at a time. They are powered by massive black holes at the centers of galaxies into which entire stars are falling, up to several per day for a large quasar, shredded by tidal effects as they spiral in. Intense magnetic fields channel some of the gravitational energy back out in the form of jets of high-energy particles, which illuminate the surrounding gas with the power of a trillion suns. Trillion suns. This is astronomical and huge. Conditions are still more extreme in the black hole's interior, within the surface of no return known as the event horizon, where the very fabric of space and time may be being ripped apart. All this is happening in a relentlessly expanding universe that began about 14 billion years ago with an all-encompassing explosion, the Big Bang, that makes all the other phenomena I have described seem mild and inconsequential by comparison. And that whole universe is just a sliver of an enormously larger entity. The multiverse or multiverse, which includes vast numbers of such universes. The physical world is not only much bigger and more violent than it once seemed, it is also immensely richer in detail, diversity and incident, yet it all proceeds according to elegant laws of physics that we understand in some depth. I do not know which is more awesome, the phenomena themselves or the fact that we know so much about them. How do we know? One of the most remarkable things about science is the contrast between the enormous reach and power of our best theories and the precarious local means by which we create them. No human has ever been at the surface of a star, let alone visited the core where the transmutation happens and the energy is produced. Yet we see those cold dots in our sky and know that we are looking at the white-hot surfaces of distant nuclear furnaces. Physically, that experience consists of nothing other than our brains responding to electrical impulses from our eyes. And eyes can detect only light that is inside them at the time. The fact that the light was emitted very far away and long ago, and that much more was happening there than just the emission of light, those are not things that we see. We know them only from the theory. Scientific theories are explanations, assertions about what is out there and how it behaves. Where do these theories come from? For most of the history of science, it was mistakenly believed that we derived them from the evidence of our senses, a philosophical doctrine known as empiricism. So here is a diagram that shows sensory experiences towards derivation, such as extrapolation, generalization, or induction, towards theories or knowledge of reality. So this is called empiricism, according to the author. For example, the philosopher John Locke wrote in 1689 that the mind is like white paper onto which sensory experience writes, and that is where all our knowledge of the physical world comes from. Another empiricist metaphor was that one could read knowledge from the book of nature by making observations. Either way, the discoverer of knowledge is its passive recipient, not its creator. But in reality, scientific theories are not derived from anything. We do not read them in nature, nor does nature write them into us. They are guesses, bold conjectures. Human minds create them by rearranging, combining, altering, and adding to existing ideas with the intention of improving upon them. We do not begin with white paper at birth, but with inborn expectations and intentions and an innate ability to improve upon them using thought and experience. Experience is indeed essential to science, but its role is different from that supposed by empiricism. It is not the source from which theories are derived. Its main use is to choose between theories that have already been guessed. That is what learning from experience is. Wow, what an amazing paragraph. What an amazing section. I'm going to read it, this section, because I am enthralled by this idea because of its uniqueness. For example, the philosopher John Locke wrote in 1689 that the mind is like white paper onto which sensory experience writes, and that is where all our knowledge of the physical world comes from. Another empiricist metaphor was that one could read knowledge from the book of nature by making observations. Either way, the discoverer of knowledge is its passive recipient, not its creator. But in reality, scientific theories are not derived from anything. They are guesses, bold conjectures. Human minds create them by rearranging, combining, altering, and adding to existing ideas with the intention of improving upon them. We do not begin with white paper at birth, but with inborn expectations and intentions and an innate ability to improve upon them using thought and experience. Experience is indeed essential to science, but its role is different from that supposed by empiricism. It is not the source from which theories are derived. Its main use is to choose between theories that have already been guessed. That is what learning from experience is. So now let me just explain what I've learned so far from these first 4 pages. So the first page discusses the vastness of the universe and the concept of transmutation. It begins by comparing the limited view of the universe that humans have with the reality of the stars and their immense distances. The text then explains that stars are powered by nuclear energy released through transmutation, a process that converts one element into another. This concept, while ancient and pursued by alchemists, was not fully understood until the 20th century. This text concludes by noting that transmutation also occurs naturally on Earth in the decay of radioactive elements. And then the next page this describes the vastness of the universe and the incredible phenomena that occur within it. It discusses the Milky Way galaxy, supernova, and quasars, highlighting their immense scale and energy output. And the space also emphasizes the potential dangers of these cosmic events, such as the devastating effects of supernova on planets and the destructive power of gamma ray bursts. Finally, it notes the importance of supernova in the formation of elements essential to life. And then the next page, which is third page, discusses the vastness of the universe and the incredible phenomena that occur within it, such as quasars and black holes. It highlights the contrast between the immense scale of these phenomena and the local means by which humans create scientific theories to explain them. The text emphasizes that despite the limitations of human observation, we can understand and explain these phenomena through the power of scientific theories. The next page, page number 4, discusses the history of empiricism, a philosophical doctrine that posits that knowledge of reality is derived from sensory experiences. Again, a philosophical doctrine which is known as empiricism, that it posits that knowledge of reality is derived from sensory experiences. It critiques empiricism, arguing that scientific theories are not derived from experience but rather created through human ingenuity and imagination. The text emphasizes the importance of experience in choosing between theories but asserts that it is not the source of their creation. It highlights the work of Karl Popper, who challenged the empiricist view in the mid-20th century. So this section is fascinating. However, that was not properly understood until the mid-20th century with the work of the philosopher Karl Popper. So historically, it was empiricism that first provided a plausible defense for experimental science as we now know it. Empiricist philosophers criticized and rejected traditional approaches to knowledge, such as deference to the authority of holy books and other ancient writings, as well as human authorities such as priests and academics, and belief in traditional lore, rules of thumb, and hearsay. Empiricism also contradicted the opposing and surprisingly persistent idea that the senses are little more than sources of error to be ignored. And it was optimistic, being all about obtaining new knowledge, in contrast with the medieval fatalism that had expected everything important to be known already. Thus, despite being quite wrong about where scientific knowledge comes from, empiricism was a great step forward in both the philosophy and history of science. Nevertheless, the question that skeptics, friendly and unfriendly, raised from the outset always remained: how can knowledge of what has not been experienced possibly be derived from what has? What sort of thinking could possibly constitute a valid derivation of the one from the other? No one would expect to deduced a geography of Mars from a map of Earth. So why should we expect to be able to learn about physics on Mars from experiments done on Earth? Evidently, logical deduction alone would not do, because there is a logical gap. No amount of deduction applied to statements describing a set of experiences can reach a conclusion about anything other than those experiences. The conventional wisdom was that the key is repetition. If one repeatedly has similar experiences under similar circumstances, then one is supposed to extrapolate or generalize that pattern and predict that it will continue. For instance, why do we expect the sun to rise tomorrow morning? Because in the past, so the argument goes, we have seen it do so whenever we have looked at the morning sky. Again, this is fascinating. Why do we expect the sun to rise tomorrow morning? And because in the past, so the argument goes, we have seen it do so whenever we have looked at the morning sky. From this, we supposedly derive the theory that under similar circumstances we shall always have that experience, or that we probably shall. On each occasion when that prediction comes true, and provided that it never fails, the probability that it will always come true is supposed to increase. Is supposed to increase. Thus, one supposedly obtains ever more reliable knowledge of the future from the past, and of the general from the particular. That alleged process was called inductive inference or induction, and the doctrine that scientific theories are obtained in that way is called inductivism. To bridge the logical gap, some inductivists imagine that there is a principle of nature, the principle of induction, that makes inductive inferences likely to be true. The future will resemble the past is one popular version of this. And what is that? The future will resemble the past is one popular version of this, and one could add the distant resembles the near, the unseen resembles the seen, and so on. But no one has ever managed to formulate a principle of induction that is usable in practice for obtaining scientific theories from experiences. Historically, criticism of inductivism has focused on that failure and on the logical gap that cannot be breached, but that lets inductivism off far too lightly. But that lets inductivism off far too lightly. For it concedes inductivism's two most serious misconceptions. First, inductivism purports to explain how science obtains predictions about experiences, but most of our theoretical knowledge simply does not take that form. Scientific explanations are about reality, most of which does not consist of anyone's experiences. Astrophysics is not primarily about us, what we shall see if we look at the sky, but about what stars are, their composition, and what makes them shine, and how they formed, and the universal laws of physics under which that happened. Most of that has never been observed. No one has experienced a billion years or a light year. No one could have been present at the Big Bang. No one will ever touch a law of physics except in their minds through theory. Right. This is obvious and true. I am reading it again. Most of that has never been observed. No one has experienced a billion years or a light year, no one could have been present at the Big Bang. No one will ever touch a law of physics, except in their minds through theory. All our predictions of how things will look are deduced from such explanation of how things are. So inductivism fails even to address how we can know about stars and the universe as distant from just dots in the sky. The second fundamental misconception in inductivism is that scientific theories predict that the future will resemble the past and that the unseen resembles the seen and so on, or that it probably will. But in reality, the future is unlike the past. The unseen very different from the seen. Science often predicts and brings about phenomena spectacularly different from anything that has been experienced before. For millennia, people dreamed about flying, but they experienced only falling. Then they discovered good explanatory theories about flying, and then they flew in that order. Before 1945, no human being had ever observed nuclear fission, atomic bomb explosion. There may never have been one in the history of the universe. Yet the first such explosion and the conditions under which it would occur had been accurately predicted, but not from the assumption that the future would be like the past. Even sunrise, that favorite example of inductivists, is not always observed every 24 hours. When viewed from orbit, it may happen every 90 minutes or not at all. And that was known from theory long before anyone had ever orbited the Earth. It is no defense of inductivism to point out that in all those cases the future still does resemble the past in the sense that it obeys the same underlying laws of nature, for that is an empty statement. Any purported law of nature, true or false, about the future and the past is a claim that they resemble each other by both conforming to that law. So that version of the principle of induction could not be used to derive any theory or prediction from experience or anything else. Even in everyday life, we are all aware that the future is unlike the past and are selective about which aspects of our experience we expect to be repeated. Before the year 2000, I had experienced thousands of times that if a calendar was properly maintained and used the standard Gregorian system, then it displayed a year number beginning with 19, yet at midnight on 31 December 1999, I expected to have the experience of seeing a 20 on every such calendar. I also expected that there would be a gap of 17,000 years before anyone experienced a 19 under those conditions again. Neither I nor anyone else had ever observed such a 20 nor such a gap. But our explanatory theories told us to expect them, and expect them we did. As the ancient philosopher Heraclitus, forgive me for my pronunciation. My pronunciation for Greek names or some English names may be incorrect, but know that there are other ways to pronounce the name. Heraclitus remarked, "No one ever steps in the same river twice, for it is not the same river and he is not the same man." What? As the ancient philosopher Heraclitus remarked, "No one ever steps in the same river twice, for it is not the same river and he is not the same man." So when we remember seeing sunrise repeatedly under the same circumstances, we are tacitly We are tacitly relying on explanatory theories to tell us which combinations of variables in our experience we should interpret as being repeated phenomena in the underlying reality and which are local or irrelevant. For instance, theories about geometry and optics tell us not to expect to see a sunrise on a cloudy day, even if a sunrise is really happening in the unobserved world behind the clouds. Only from those explanatory theories do we know that failing to see the sun on such days does not amount to an experience of its not rising. Similarly, theory tells us that if we see a sunrise reflected in a mirror or in a video or a virtual reality game, that does not count as seeing it twice. Thus, the very idea that an experience has been repeated is not itself a sensory experience, but a theory. Theory, yes. So much for inductivism. And since inductivism is false, empiricism must be as well. For if one cannot derive predictions from experience, one certainly cannot derive explanations. Discovering a new explanation is inherently an act of creativity. To interpret dots in the sky as white-hot, million-kilometer spheres, one must first have thought of the idea of such spheres, and then one must explain why they look small and cooled and seem to move in lockstep around us and do not fall down. Such ideas do not create themselves, nor can they be mechanically derived from anything. They have to be guessed, after which they can be criticized and tested. To the extent that experiencing dots writes something into our brains, it does not write explanations but only dots. Nor is nature a book. One could try to read the dots in the sky for a lifetime, many lifetimes, without learning anything about what they really are. Historically, that is exactly what happened. For millennia, most careful observers of the sky believed that the stars were lights embedded in a hollow, rotating celestial sphere centered on the earth, or that they were holes in the sphere through which the light of heaven shone. This geocentric, earth-centered theory of the universe seemed to have been directly derived from experience and repeatedly confirmed. Anyone who looked up could directly observe the celestial spheres and the stars maintaining their relative positions on it and being held up just as the theory predicts. Yet in reality, the solar system is heliocentric, centered on the sun, not the earth, and the earth is not at rest but in complex motion. Although we first noticed a daily rotation by observing stars, it is not a property of the stars at all, but of the earth and of the observers who rotate with it. It is a classic example of the deceptiveness of the senses. The earth looks and feels as though it is at rest beneath our feet, even though it is really rotating. As for the celestial sphere, despite being visible in broad daylight as the sky, it does not exist at all. The deceptiveness of the senses was always a problem for empiricism, and thereby it seemed for science. The empiricist's best defense was that the senses cannot be deceptive in themselves. What misleads us are only the false interpretations that we place on appearances. That is indeed true, but only because our senses themselves do not say anything. Only our interpretations of them do, then those are very fallible. But the real key to science is that our explanatory theories, which include those interpretations, can be improved through conjecture, criticism, and testing. Empiricism never did achieve its aim of liberating science from authority. It denied the legitimacy of traditional authorities, and that was salutary. But unfortunately, it did this by setting up two other false authorities: sensory experience and whatever fictitious process of derivation, such as induction, one imagines is used to extract theories from experience. The misconception that knowledge needs authority to be genuine or reliable dates back to antiquity, and it still prevails. To this day, most courses in the philosophy of knowledge teach that knowledge is some form of justified true belief, where justified means designated as true or at least probable by reference to some authoritative source of touchstone of knowledge. Thus, how do we know is transformed into by what authority do we claim. The later question is a chimera that may well have wasted more philosophers' time and effort than any other idea. It converts the quest for truth into a quest for certainty, a feeling, or for endorsement, a social status. This misconception is called Justificationism. The opposing position, namely the recognition that there are no authoritative sources of knowledge nor any reliable means of justifying ideas as being true or probable, is called fallibilism. To believers in the justified true belief theory of knowledge, this recognition is the occasion for despair or cynicism, because to them it means that knowledge is unattainable. But to those of us for whom creating knowledge means understanding better what is really there and how it really behaves, and why fallibilism is part of the very means by which this is achieved. Fallibilists expect even their best and most fundamental explanations to contain misconceptions in addition to truth, and so they are predisposed to try and change them for the better or the better. In contrast, the logic of justificationism is to seek, and typically to believe, that one has found ways of securing ideas against change. Moreover, the logic of fallibilism is that one not only seeks to correct the misconceptions of the past, but hopes in the future to find and change mistaken ideas that no one today questions or finds problematic. So it is fallibilism, not mere rejection of authority, that is essential for the initiation of unlimited knowledge growth, the beginning of infinity. The quest for authority led empiricists to downplay and even stigmatize conjecture, the real source of all our theories. For if the senses were the only source of knowledge, then error, or at least avoidable error, could be caused only by adding to, subtracting from, or misinterpreting what the source is saying. Thus, empiricists came to believe that in addition to rejecting ancient authority and tradition, scientists should suppress or ignore any new ideas they might have, except those that had been properly derived from experience. As Arthur Conan Doyle's fictional detective Sherlock Holmes put it in the short story A Scandal in Bohemia, it is a capital mistake to theorize before one has data. But that was itself a capital mistake, We never know any data before interpreting it through theories. All observations are, as Popper put it, theory-laden, and hence fallible, as all our theories are. Consider the nerve signals reaching our brains from our sense organs. Far from providing direct or untainted access to reality, even they themselves are never experienced for what they really are, namely crackles of electrical activity, nor, for the most part, do we experience them as being where they really are, inside our brains. Instead, we place them in the reality beyond. Beyond. We do not just see blue, we see a blue sky up there, far away. We do not just feel pain, we experience a headache or a stomach ache. The brain attaches those interpretations, head, stomach, and up there, to events that are in fact within the brain itself. What? The brain attaches those interpretations, head, stomach, and up there, to events that are in fact within the brain itself. Our sense organs themselves and all the interpretations that we consciously and unconsciously attach to their outputs are notoriously fallible, as witness the celestial sphere theory, as well as every optical illusion and conjuring trick. So we perceive nothing as what it really is. It is all theoretical interpretation, conjecture. Conan Doyle came much closer to the truth when, during the Boscombe Belly mystery, he had Holmes remark that circumstantial evidence about unwitnessed events is a very tricky thing. It may seem to point very straight to one thing, but if you shift your own point of view a little, you may find it pointing in a equally uncompromising manner to something entirely different. There is nothing more deceptive than an obvious fact. The same holds for scientific discovery, and that again raises the question, how do we know? If all our theories originate locally as guesswork in our own minds and can be tested only locally by experience, how is it that they contain such extensive and accurate knowledge about the reality that we have never experienced? The term was coined by the philosopher Norwood Russell Hanson, the term theory-laden. Okay, so up until now, I have read the first 10 pages of the books. Now I am going to discuss what I have learned from reading these later pages. So the fifth page discusses the history of empiricism and its limitations. It argues that while empiricism was a significant step forward in scientific inquiry, it is flawed in its belief that scientific knowledge is solely derived from sensory experiences. The text highlights the logical gap between past experiences and future predictions and criticizes the concept of induction as a means to bridge this gap. It concludes by noting that no practical principle of induction has been formulated to guide the derivation of scientific theories from experiences. And the next page, which is page number 6, so far I am concerned, the page number 5 discusses the history of empiricism and its limitations. It argues that while empiricism was a significant step forward in scientific inquiry, it is flawed in its belief that scientific knowledge is solely derived from sensory experiences. The text highlights the logical gap between past experiences and future predictions and criticizes the concept of induction as a means to bridge this gap. It concludes by noting that no practical principle of induction has been formulated to guide the derivation of scientific theories from the experiences. And then the next page 6 continues to critique the concept of induction, arguing that it fails to explain how scientific theories are derived from experiences and how they can predict the future. It emphasizes that scientific explanations are primarily about reality, not just experiences, and that many aspects of reality, such as the formation of the stars and the laws of physics, have never been directly observed. Right. Like, no one was alive there when the Big Bang or our universe began. We just can talk about them with guesses or conjecture and experiments that we conduct on the lab, which does not necessarily ensure 100% accurate information. That does it? No, I think it doesn't. At least I don't know for sure. So the page also challenges the idea that the future will resemble the past, pointing out that scientific theories often predict and bring about new phenomena that are different from anything previously experienced. And then the page 7, again, it continues to critique the concept of induction and empiricism. It argues that induction is a false principle that cannot be used to derive predictions or explanations from experience. The page emphasizes that the idea of repeated experiences is itself a theory, not a sensory experience, and that it is based on explanatory theories that tell us which aspects of our experience to interpret as repeated phenomena. It concludes by asserting that discovering new explanation is an act of creativity that cannot be derived solely from experience. So this is also a form of creativity. Well, I think most humans are creative, as they can observe things and tell what they see. And the page 8 continues to critique the concept of induction and empiricism. It argues that induction is a false principle that cannot be used to derive predictions or explanation from experience. Right. And so it also continues to discuss the limitations of empiricism and the importance of explanatory theories in scientific inquiry. It argues that sensory experiences alone cannot provide explanations, and that these explanations must be guessed and then critically evaluated. The text highlights the historical example of the geocentric theory, which was based on sensory observations but ultimately proven to be incorrect. It emphasizes that the deceptiveness of the senses is a challenge for empiricism, but that the key to science lies in the ability to improve explanatory theories through conjecture, criticism, and testing. And then the page 9 discusses the history of empiricism and its limitations. Again, it critiques the concept of justificationism, which posits that knowledge requires authoritative sources or justification. This text also advocates for fallibilism, which recognizes that there are no authoritative sources of knowledge and that even the best explanations are subject to error. Fallibilists believe that knowledge is achieved through understanding and correcting misconceptions, and they are open to changing their ideas in the pursuit of better explanations. And also some sections here emphasizes that fallibilism is essential for the growth of knowledge and the initiation of unlimited progress. And then the page number 10 I think it discusses the limitations of empiricism and the importance of explanatory theories in scientific inquiry. It critiques the idea that scientific knowledge should be derived solely from experience and argues that all observations are theory laden and fallible. The text emphasizes that our senses are deceptive and that we perceive nothing as to what is truly is. It highlights the importance of conjecture and critical evaluation in scientific discovery and questions how theories originating in our minds can contain extensive and accurate knowledge about the reality we have never experienced. So, no more today. I will read the next 10 pages from 11 to 20 on the next day. So look, I just purchased these books yesterday, and as I started reading the book, I also want to share and talk about what I learned from reading my from reading the book. So if you like and want to discuss any particular topic, please write your comment in the comment section. I'm curious to learn about your thoughts so that we can have either a constructive criticism or talk or discuss further into the topic with real life examples that we encounter in our everyday life. So with that, take care and come back tomorrow to listen to the next part.